Hey everyone, welcome to your 7-5 video, which is using proportional relationships. What we're going to look at today is indirect measurement. So indirect measurement is anytime we're using proportions or similar figures in order to find the length of an object that we normally can't just walk up to and use a ruler. So for example, if we wanted to find the height of a building, we could use an indirect measurement to find the height rather than trying to have somebody standing at the top of a building and somebody standing at the bottom and trying to hold a really long measuring tape. Okay, so that's something that is difficult to measure directly, so we're going to use indirect measurement. So one of the things that we're looking at here, if we start by looking at example 1, we have a student wants to find the height of a statue of a pineapple in Australia. So the student measures the pineapple's shadow and her own shadow. And her height is 5 feet 4 inches. We want to know the height of the pineapple. So the first thing that we're looking at here is that we are looking for the height of the pineapple right here. So I'm going to go ahead and call that X. Okay. Now, what we need to realize is if she's 5 feet 4 inches, then two of our measurements here have a combination of feet and inches. And we want to change that so that we only have one unit of measure. Now, if we look at 5 feet 4 inches, 4 inches is 1/3 of a foot. That's going to give us a never-ending decimal, which is going to make our ratios and our proportions really difficult to set up. So what we're going to start by doing is we are going to convert everything to inches first, okay? Because again, the reason we're doing this is because this here is going to give us a never-ending decimal, okay? Sometimes it's easier to go to inches and then you can kind of convert back. So let's take a look at all of our measurements here. So 2 feet in inches is going to be 24 inches. Because remember, 12 inches in a foot, 2 times 12. All right, 5 feet 4 inches. Okay, 5 feet is 5 times 12, so that's 60 inches. Plus 4 is going to be 64 inches. Okay, and then the last one is 8 feet 9 inches. And that's going to give us 8 times 5 is plus 9 is going to give, or 8 times 5, excuse me. 8 times 12 plus 9 is going to give us 105 inches. All right, so now when I'm looking at my two triangles, this is what I'm looking for. This is going to be 105. This is 64 and this is 24. All right, so that just kind of makes our setup a little bit easier. Now, our triangles are similar. They're both right angles. And the reason when we look at shadows, because the angle of the sun is going to be the same. Okay, so we know that angles 1 and 2 are going to be congruent here because the angle that the sun makes with the pineapple and the girl, the shadows are going to go in the same direction. All right, so we're going to set up 64 over x, so it's going to be the height over the height. So 64 over x is going to equal, then we're going to do the shadow over the shadow, and we're going to do 24 over 105. So when we cross multiply, we're going to get 24x is equal to 64 times 105, which is 6,720. All right, when we divide both sides by 24, I'm going to get 280. So it's going to be either 280 inches, 280, or if we take that and divide it by 12, that's going to be 23 feet, and it's 3 repeating. Well, 3 repeating is 1/3, which is 4 inches. So these are your answers here. Okay. When we are doing these in for your tests and quizzes and whatnot, I will be sure to tell you whether you are doing inches or if I want your answer in feet. If I don't tell you, it won't matter which is which. I'll take both answers, okay? But I will do my best to make that clear whether you want inches or whether you want feet. All right. If you have any questions on that, go ahead and write that on your notes right now. And then we're going to go ahead and look at scale drawings. Okay, again, we've kind of talked about how similarity is one of the places that's super real world. It's a lot of connections to real life things because of things like scale drawings. Okay, so scale drawings are maps, or again, any representation of something that is large that you can draw small. So when we look at scale drawings, a scale is how long it is on a map versus how long it is in real life. So if we look at this example here, for every 1.5 centimeters on the map, that represents 300 meters in real life. So what we're looking at is we want to find the space between, or the distance between Union Station, which is right here, and the Dallas Public Library, which is right here. So I'm basically trying to figure out how long this is right here. If we know that on the map, they're 7.5 centimeters apart. So what I do to set these up, okay, I'm going to set up the scale over the actual. So my scale on the map is 1.5 centimeters. The actual length is 300 meters. So on my map, they're 7.5 centimeters apart. So that's on my scale, and then I'm looking for the actual distance that they are apart. So then from here, we can cross multiply. We're going to get 1.5x, and then 300 times 7.5 is 2,250. And when I divide that by 1.5, I'm going to get that x is going to be 1,500. And again, this is the actual length, so our actual unit was in meters. All right, so if you have any questions on any of that, go ahead and write that down now. And then we're going to go ahead and look at another, again, still working with that scale. We want to, if the the Lincoln Memorial in Washington, D.C. is 57 meters long. So that means this length here is the 57 meters, and it's 36 meters wide. Well, that's really the height, okay? So if we look at it, we can tell it's shorter than it is long. So they're saying that this is the 36 meters. All right. It says make a scale drawing, but what I really want you to identify when it says this is what is the length and width of the scale drawing. Okay, you don't have to actually draw it out. I just want you to identify, okay, in the scale drawing, it would be this long by this wide. Okay, and the scale that we want to use is 1 centimeter is representing 15 meters. So we have to do this in two parts. All right, I know that if my scale is 1 to 15, all right, and my actual length, because remember 57 was our length, is 57 meters. I'm looking for how long it's going to be in the scale. So again, I'm going to do that actual length, or excuse me, that scale length over the actual length. So it's going to be 1 over 15. Now, again, I have to do these separately for length and for width. So when I look at the length, my scale length is what I don't know. So I'm going to just put an L there for that. My actual length is 57. So now we're going to cross multiply. I'm going to get 15L is equal to 57. And then I'm going to divide 57 by 15, which is going to give me 3.8. Okay. Now I have to do that exact same thing, except with the width. So I'm going to do the same setup. That 1 over 15 is my scale. Okay, that's here. And then my width of my scale is what I'm trying to find. So I'm going to put a W. And then the actual width over here is 36. So again, we're going to cross multiply. I'm going to get 15W is equal to 1 times 36, which is 36. Divide both sides by 15, and I'm going to get 2.4. So in my scale drawing, the length is going to be 3.8 centimeters, and the width is going to be 2.4 centimeters. Okay, so that is what I'm looking for when it says make a scale drawing. Again, I'm not worried about you actually drawing something that is 3.8 centimeters by 2.4 centimeters. Just give me the length and the width and what they are going to be. All right, if you have any questions on that, go ahead and write that down now. Okay, the next thing that we're going to look at is the relationship that the similarity ratio has with the perimeter ratio and the area ratio. Okay, so when I look at my perimeter or my scale factor here, okay, my similarity ratio, if I do little to big, that's 5 to 10, which is 1/2, or 4 to 8, which is 1/2, or 3 to 6, which is 1/2. So my similarity ratio here for this example is 1/2 if I go little to big. Okay, my perimeter is 3 plus 4 plus 5 in this triangle. So 3 plus 4 plus 5 is going to give me 12. And over here, I'm going to do 10 plus 8 plus 6, and that's going to give me 24. Well, look, 12 over 24 is still 1/2. All right, then I'm going to do my area. Remember, area is 1/2 base times height for a triangle. So I'm going to do 1/2 3 times 4, which is going to give me 6. And over here, I'm going to do 1/2 6 times 8 to give me 24. So 6 over 24 is 1/4, which is the same thing as saying 1/2 squared. Okay, so this is the important part here. Okay, your similarity ratio and your perimeter ratio are the same. Okay, your similarity ratio, your perimeter ratio, they do not change. It's going to be just like it was up here, 1/2 to 1/2, or whatever numbers. Okay, they're not always going to be 1/2. Your area ratio is always going to be that similarity ratio squared. So a squared over b squared. All right, it is really important that you understand this. Okay, and if you think about it in terms of units, we do our if we find the lengths of the sides, those are in inches or meters or centimeters or whatever. If you add up all the sides, it's still in inches or meters or centimeters or whatever. But when you find an area, it's inches squared. All right, well, it's your same thing here. Your similarity and your perimeter are the same, and you don't mess with it. Your area, you're going to square it. So let's take a look at how that's going to work in a problem. All right, I want to find the perimeter and the area of this figure over here. So what I want to start by doing, okay, is I'm going to come over here to the side, and I'm going to write down all of my ratios. I am going to start with the similarity ratio. Okay, my similarity ratio is, remember, just one side over the other. For sake of ease, I'm just going to go left to right or little to big. All right, so my similarity ratio is 16 over 20, which is the same thing as if we simplify. Okay, those are both divisible by 4. This is going to be 4/5 for my similarity ratio. Okay, now we're going to look at our perimeter ratio. Our perimeter ratio is the same as our similarity ratio. It is also going to be 4/5. All right, my area ratio is going to be that similarity ratio squared. Okay, so 4 squared is 16. 5 squared is 25. Don't forget, you have to square both the top and the bottom. All right, this is really important because what we're going to do now is we're going to do two different proportions. One of them to find the perimeter, one of them to find the area. All right, when we're going to find perimeter, I want to make sure that I'm using my perimeter ratio. All right, so when I find perimeter, my perimeter ratio is 4/5. I have to start the proportion with the perimeter ratio if I'm trying to find perimeter. Okay, so this is little to big. My little perimeter was 36 feet, so it's going to be 36. I don't know my larger perimeter, so I'm just going to put in a P for perimeter. All right, now we're going to cross multiply. I'm going to get 4P is equal to 5 times 36, which is 180. When I divide both sides by 4, I'm going to get that P is 45. So the perimeter is 45 feet for triangle WVU. Okay? Now, I also want to find the area. Okay? If I'm using area, I need to start with my area ratio. Again, area means you need to start with your area ratio. I can't stress that enough. So this is going to be 16 over 25. Okay, my smaller area is 48. I'm looking for my bigger area, so I'm just going to put in A for area. So again, we're going to cross multiply. I'm going to get 16A equals 25 times 48, which is 1200. I'm going to divide both sides by 16, and this is going to give me 75. Okay, again, our unit is in feet, and area is, our unit is feet squared. Okay, remember your area units are always squared. Okay, if you have any questions on that, please make sure that you write them down. Again, I can't stress it enough. Perimeter means perimeter ratio. Area means area ratio. Always start by finding all of your ratios off to the side. That will help you remember. Use perimeter for perimeter, area for area. All right. Go ahead, and the next thing that we're going to do is we're going to pause the video, and you've got 2 on your own on your paper. So why don't you go ahead, take a minute, get those done. I will give you a hint for the first one, that right here, that it is easier to take this to inches and to take this to inches, because 2 inches is going to be 1/6 of a foot, which again is a decimal that does not end, and it's annoying to deal with. Okay. So again, my suggestion when you get started is take it to inches and then go ahead and set up your proportion. All right, but go ahead and do this one and then do the next one as well. And then go ahead and play the video, and then we'll come back to this. All right, so go ahead and pause your video now. Okay, so go ahead and check your work here. Again, 5 feet 6 inches is 66 inches. 5 feet is 60 inches. 14 feet 2 inches is 170 inches. So I went ahead and started by converting this all to inches to set up my proportion. All right, cross multiply, divide by 60, I get 187 inches. Okay, when I divide that by 12, I get that it's 15 feet. And then the decimal is going to give me 7 inches out of the other 12. So it's 15 feet, 7 inches. If you want me to go over how we convert that, I can do that in class tomorrow. All right. If you have not done this problem, go ahead and pause the video now and do it. Otherwise, we're going to go ahead and go over it. All right. So go ahead and check your work. Again, you want to start by writing out your ratios over on the side. And with this one, it's also really helpful to go ahead and draw it out, because they're not going to give you a picture. So anytime you don't have a picture, draw one. It makes things easier. All right, so my perimeter ratio is going to be the ratio of my sides, which is 4 over 12, which is 1/3. Okay, in our previous problem that we did, our variable was in the denominator because we were looking for the larger figure. This time my numerator is my variable because I'm looking for the smaller one, and I went small to big. All right, same thing with the area. The area ratio is going to be 1/3 squared, so 1 squared is 1 and 3 squared is 9. Again, set up that area ratio, cross multiply and solve. Now we're going to get a never-ending decimal, so I just did 6 with the repeating bar over it. All right, if you have any questions, please make sure you write that down, and we will go over them in class tomorrow. Have a wonderful day, guys, and I'll see you later.